Welcome back to Mr. Buchynski's video tutorials. In this episode, we'll be investigating 3 pedigree examples. So the plan is to prove one type of inheritance by eliminating every other option. Be sure to check out the pedigree analysis video so you know how we will be proceeding through these examples. So here's the first example. It looks a little bit daunting. What we're going to do is we're going to try and break it into smaller chunks, and we're going to initially just try to determine, like our little steps from before, we're going to try and determine if it's either recessive or dominant. So initially what jumps out to me is I can see right here that 2 unaffected individuals are creating an affected son, so that's immediately telling me that it's a recessive condition. We've taken a guess that the condition is recessive, and we can see that in this family here and in this family here, so it's definitely good evidence for a recessive condition. Since we've determined that it's a recessive condition, we need to find an affected female. I'm going to look at this one right here, because what I can see is when I look at her male children, we know that she's homozygous recessive for the condition. If it was on the X chromosome, she would have no choice but to donate it to her 2 sons here and here. And that's actually not the case. So we definitely know that this is not a sex-linked recessive. We concluded that it is recessive condition, and our red text here shows us we further concluded that it's not a sex-linked recessive condition, so it obviously must be an autosomal recessive condition. Even though we've already discovered what it is, it's never a bad idea to disprove the other one, so let's just look at maybe a sex-linked dominant. We would need to find an affected male. Here's one right here, and what we can do is we can see that his mother is also unaffected by the condition, so it definitely cannot be a sex-linked dominant. This same grouping also determines that it is not autosomal dominant either. And we know this because if the son has the condition, then one of the parents must also have the condition if it was dominant. We could also disprove that it is a Y-linked condition, one, because girls are present with the condition, they do not have a Y chromosome, and even this father right here does not pass it on to his son, so we know it's not Y-linked. Excellent, so we have that one done. It's not as bad. Obviously we are disproving everything, so it has no choice but to be autosomal recessive. So let's go on to the next example. Alright, this one's a little bit smaller, not too bad. What we're going to do, we're going to still bite it into small chunks, and we're going to check to see whether it's recessive or a dominant condition. Right off the bat again, I can see that 2 unaffected individuals creating an affected individual, and that's leading me to believe that we have a recessive condition. Now we need to determine whether it's a sex-linked condition, and how we can do that is we're going to look at an affected female. We can look at this one here or this one here. It doesn't matter. Let's look at this one here to start. We can see that this female right here has 2 out of 2 affected sons. That is very strong evidence for a sex-linked recessive. Now there's no way to actually prove that it's sex-linked recessive. Some more evidence that would be very strong and would help us determine this would be is if this affected female also had an affected father, because in a sex-linked recessive condition, that's always going to be more evident in males than in females, because males only have one X. Therefore, if they have the recessive allele, they will be showing that condition. So we can conclude that it's likely sex-linked recessive. Just to be safe, let's disprove all other theories. We know if we have an affected male, if it was any sort of sex-linked dominant, we know that his mother would have to be affected. This is not the case in the green box, so we know that it is not sex-linked dominant. Looking at it from an autosomal point of view, it's also going to show that it's not autosomal dominant because one of the parents would have also had to have the condition as well. So it's not autosomal dominant. The last one we can disprove is whether it's Y-linked. We definitely know it's not Y-linked because of there are females affected. That's definitely the easiest one to see. What we're going to do is we are going to move on to our last example. Here we go. Again, let's start from whether it is either dominant or recessive. And this one's a little bit trickier, but I can actually see right here that two affected parents are creating a unaffected son, so that's likely leading and pointing to some sort of dominant inheritance. Since it is a dominant inherited condition, what we're going to do, we're going to check out the affected males, and if we can manage to find one with a normal daughter or a normal mother, we know that it is not sex-linked dominant because we can understand that that dominant X that the affected male must have, it's going to be coming from mom and it's going to be given to daughter 100% of the time. So if we can find that, and it just so happens right here, we can see that this is an unaffected daughter right here. So what we can conclude, it is not sex-linked dominant. Because it's not sex-linked dominant, and we do know that it is dominant, we can actually conclude that it is an autosomal dominant inheritance. Just to be safe, let's disprove every other possibility. We know that two affected individuals, if it was autosomal recessive, then every child must have it. In this case, it's not the case, so we know that it's not autosomal recessive. We're missing sex-linked recessive and Y-linked. Let's disprove sex-linked recessive first. So if we can find an affected female, let's use this one right here. And what we're going to do is we can see that she has an unaffected son, so there's no possible way that it can be sex-linked recessive. So let's write that in. And lastly, the easy one, let's prove why it's not Y-linked. Well, we can see right here that it is not passed on to son, so we know that's not Y-linked. And also we can see throughout that there are affected females everywhere, so we know that it's not a Y-linked inheritance as well. That's the end of this episode. So hopefully you have a better understanding of how to prove and disprove particular inheritances within a pedigree. Always remember that this is the path to go through. Always start from a either dominant or recessive beginning, and then further clarify it into either autosomal or sex-linked afterwards. and that is
Now
the
that
way
you've
to
seen
go.
3 examples completed, hopefully you have a better idea how to progress through and solve for a type of inheritance in any type of pedigree. It's important just to go step by step, taking a little step at a time, but always make sure that you've eliminated every other option. Make sure you've proved that every other option is not possible. Hopefully this was helpful, and ideally you increased your knowledge on the concept. So thanks for listening, and I'll catch you in the next episode.